Everyone has been calling AI a software play. Smarter models, better apps, more subscriptions. That is the story everyone understands. But then Morgan Stanley says something that does not sound like software at all. By the end of 2028, AI needs $3 trillion of physical infrastructure. $3 trillion for something most people experience as a chat box. This is not software money. This is the kind of money you spend when you build a country-scale industrial system. Project Apollo was about $309 billion in today's dollars. The interstate highway system was about $500 billion. The Manhattan Project was a little over $30 billion. AI infrastructure is being talked about in trillions. So here is the question. If AI lives inside a chat box, where does the $3 trillion actually go? In the next 10 minutes, we are going to follow that money down the stack. Not the hype, the money. By the end, you should understand which layers get paid first, which layers get paid the most, and where the real opportunities in the AI boom could be hiding over the next 5 years. Here is the money map. Think of the $3 trillion AI boom as a stack. At the top, the app and the model. That is what users see, but it is not where most of the money goes. Then comes about $900 billion for the brains, GPUs, CPUs, and custom AI chips. Another $300 billion for the fuel line, memory and advanced packaging that feed those chips fast enough to make them useful. Another $400 billion for the nervous system, networking, servers, and racks that turn thousands of chips into one working machine. That is the $1.6 trillion hardware bill. Then comes about $1.3 trillion for the body, land, buildings, electrical rooms, substations, construction, maintenance, and security. Then at least $300 billion more for power and cooling. And underneath the whole thing is the layer most people ignore, financing. Because even after big tech pays for a huge part of this, there is still a $1.5 trillion gap that has to be financed somehow. That is the stack. Apps at the top, debt at the bottom, and in between, the physical machine that makes AI possible. Now let's walk down the stack. The first layer is the app. ChatGPT, Claude, Gemini, Copilot, Perplexity, Cursor. This is where the user is. This is where the subscription button is. This is where the magic appears to happen. But the app is only the front door. The expensive part starts after you press send. Behind the app is the model. And this is where AI breaks the old software model. A normal app can show the same page to 1 million people. Once the code is written, serving one more user can be cheap. AI is different. Every time you ask a question, the model has to run. Training is how you build the model. Inference is what happens every time the model answers you. And inference is where usage turns directly into cost. Every prompt is a work order. The model reads your words, moves through billions of learned patterns, and generates the next token, then the next token, then the next token, until the answer is done. So AI is not just about building a smart model once. It is about running that model again and again for billions of people, billions of times. That is why the money falls into compute. Compute is the first giant toll booth. This is the layer people usually describe as GPUs. And yes, GPUs matter. AI is a massive amount of math, and GPUs are good at doing huge amounts of math at the same time. That is why Nvidia became the center of the AI economy. But if you only say GPUs, you miss the bigger idea. Modern AI is not just a calculator. It is becoming more like a worker. It uses tools, it searches files, it writes code, it looks at images, it plans steps, it moves data around. So the GPU does the heavy math, but the whole system has to coordinate the work. Nvidia's GB200 NVL72 shows what this means. One rack-scale system connects 72 Blackwell GPUs with 36 Grace CPUs. In plain English, this is not a normal computer. It is a giant AI engine, built so dozens of chips can behave like one machine. And that is why compute gets the first massive slice of the money. Before the chatbot can answer you, someone has to buy the machine that thinks for it. But even the fastest machine has a weakness. It needs to be fed. That brings us to memory. Memory is easy to underestimate because the word sounds boring. But think about what people actually want AI to become. Not just a chatbot that answers one prompt. An assistant that remembers your old chats, your files, your calendar, your writing style, your preferences, and your entire project history. If you ask it, write this like my last investor update, that old investor update cannot sit far away in a cold archive. If you ask it, Help me continue this project. The project context has to be ready right now. That is memory. Storage is where information sits when you are not using it. Memory is the working table where the model keeps the information it needs right now. If the GPU is the engine, memory is the fuel line. A bigger engine does not help if the fuel line is too narrow. This is why high bandwidth memory matters. Modern HBM can move more than a terabyte of data per second. That sounds technical, but the idea is simple. The AI chip is so fast that ordinary memory cannot feed it quickly enough. So the industry needs special memory placed extremely close to the processor. That is why SK Hynix, Micron, and Samsung are not just memory companies in this story. They are feeding the AI engine. But getting memory close to compute creates another problem. How do you physically connect the GPU and the memory so they behave like one system? That is advanced packaging. Not packaging like a box. Packaging as in the physical architecture that lets compute and memory sit close enough to move data at extreme speed. This is why TSMC's CoWoS became a bottleneck. An AI chip is no longer just a chip. It is a tiny city of compute and memory, packed together so data can move fast enough. But one tiny city is not enough. Frontier AI needs thousands, sometimes tens of thousands of chips working together. So the next layer is networking. Do not think of networking as internet cables. Think of it as the nervous system. If one GPU is one brain cell, the network is how all the brain cells fire together. The question is no longer, how fast is one chip? The question becomes, how fast can thousands of chips act as one machine? If the network is slow, the GPUs wait. And when the most expensive chips in the building are waiting, the bill keeps running. That is why AI data centers need extremely fast connections between chips, racks, and buildings. You will hear names like NVLink, InfiniBand, Ethernet, optical modules, and fiber. The names matter less than the job. The job is to stop expensive chips from sitting idle. Nvidia says its GB200 NVL72 rack has 130 terabytes per second of GPU to GPU communication bandwidth. That is not normal office networking. That is the nervous system you need when dozens of GPUs are trying to behave like one giant machine. And across larger clusters, this becomes a tens of billions of dollars market. AI does not just create demand for chips, it creates demand for the roads between chips. Now the money has moved through compute, memory, packaging, and networking. But all of those parts still have to become something people can install, power, service, and repair. That is the rack layer. A rack turns components into an operating machine. It has compute trays, switch trays, power shelves, cables, cooling plates, control systems, and technicians who keep the machine alive. This layer sounds boring, but it is where AI becomes physical. The IEA gives one of the best ways to feel it. An advanced AI server rack is about the size of a large refrigerator, but by 2027, it can have peak power demand equivalent to 65 households. A refrigerator-sized rack, 65 households of peak power. That is not a software object. That is an industrial object. And industrial objects need buildings. That brings us to data centers. This is where AI leaves the screen and enters the map. Now the money goes to land, construction, electrical rooms, substations, backup power, security, permits, contractors, and debt. OpenAI's Stargate project says it intends to invest $500 billion over 4 years in AI infrastructure. AWS built Project Rainier across multiple data centers with nearly 500,000 Trainium2 chips. xAI's Colossus started with 100,000 GPUs and expanded toward 200,000 GPUs. These are not app launches. These are industrial sites. This is why the AI boom starts to look less like software and more like railroads, factories, and power grids. The data center is the body of AI. The chips are the brain, but the body keeps the brain alive. And once AI has a body, it runs into the most physical bottleneck of all, electricity and heat. When thousands of GPUs run together, the problem is not just intelligence, it is temperature. The chips get hot. The racks get dense. The building needs more electricity. More electricity creates more heat. More heat requires more cooling. And the cooling system becomes its own engineering problem. The IEA estimates data center electricity consumption grows from 485 terawatt hours in 2025 to 950 terawatt hours in 2030. That is roughly double. But the more memorable number is heat. The IEA says an AI rack can need to remove heat equivalent to 30 natural gas boilers. One rack, 30 boilers of heat. Now imagine a room of racks. Now imagine a building of rooms. Now imagine multiple buildings. That is why air cooling starts to break down. At some point, trying to cool AI with air is like trying to cool a bonfire with a fan. You need liquid cooling. You need pumps, cold plates, heat exchangers, power equipment, transformers, grid connections, and backup generation. This is where companies that do not look like AI companies become AI infrastructure companies. Not because they build chatbots, because they keep the chatbot's physical body alive. At the top, AI is a text box. At the bottom, AI is electricity fighting heat. And then comes the final layer, the layer that can decide whether the whole build-out works. Who pays for all of this before the apps make enough money back? This is cloud, rent, and financing. Cloud infrastructure turns the physical AI stack into a business model. Amazon, Microsoft, Google, Oracle, and specialized AI clouds build the roads. Then, AI labs, startups, enterprises, and governments rent access. Cloud is the toll booth that brings the money back upstairs, but the timing is brutal. The infrastructure gets built now. The revenue arrives later. Morgan Stanley sees a $1.5 trillion financing gap. That means the AI boom is not only a technology story, it is also a credit story. This is where Wall Street enters the story. The next layer is financial plumbing: debt, leases, infrastructure funds, private credit, and long-term cloud contracts. The machines have to be built before the revenue is fully proven. That is the bet. And if the bet works, the winners are not only the companies building the smartest model. The winners are the companies that become unavoidable in the stack: the chip suppliers, the memory suppliers, the networking companies, the data center builders, the power equipment companies, the cooling companies, the cloud platforms, and the financiers who know how to turn a giant upfront build-out into a long-term rent machine. That is the hardware bill. Then, roughly $1.3 trillion goes to data centers and the physical world around the machines. Then $300 billion or more goes to power infrastructure. And underneath it all is the $1.5 trillion financing gap. So the $3 trillion AI boom is not one market, it is a stack. And the biggest opportunities do not only sit with the company that has the flashiest chatbot. They sit with the companies selling the machines, roads, land, electricity, cooling, and rent underneath the chatbot. That is why AI is so strange. On the screen, it looks weightless. In the real world, it is becoming one of the heaviest industries on Earth. So now we can answer the opening question. How does software spend the budget of an industrial revolution? It does not spend it as software. It spends it as chips, memory, networks, racks, buildings, power, cooling, cloud rent, and debt. Because AI looks like software on your screen, but the money is moving like an industrial revolution. If you want to understand the money machines behind the world's biggest business stories in plain English, subscribe to Money Machine Lab.